What's going on, guys? Welcome to Netsec Explain. And in this video, we're going to be talking about scanning large-scale networks with advanced Nmap techniques. Most people, after already learning Nmap, usually don't go too far beyond simple Class C networks or 256 hosts. But I'm going to be talking about networks that are much larger. Think 6 or 8,000 hosts, and these techniques can scale even further. See, when you're dealing with a volume that large, there's a few challenges that become apparent very quickly, and you'll need to adjust your approach to make up for it. In the end, this can help make the difference between a few hours of scanning or a few days. Oh, and these tips and techniques are going to be especially helpful for people going through the OSCP and Hack the Box labs, which I'll demonstrate later on. But first, let's talk about performance tuning. When it comes to performance tuning, everything is ultimately going to depend on the network. But having proper settings is going to make a huge difference in the long run, especially since the more addresses you add, the longer the network scan will take. Typically, what I do for my workflow is start with the T4 aggressive scanning mode and override its default values. The max retry value specifies the number of probes that Nmap retries on every scanned port. With T4, the default is 6. Which means that if a particular port is filtered and does not respond to a probe, Nmap will keep retrying over and over until it reaches this value. For reliable networks, I like to set this to 1 or 2 retries and pretty much leave it as default otherwise. The max round trip timeout, or RTT timeout, specifies the timeouts of the probes themselves. Before adjusting this setting, use ping or nping to test the network latency and adjust accordingly. The default for a T4 scan is 1200 milliseconds. This is a pretty high value. I usually set this to 300 milliseconds on a reliable network. Fyodor, the creator of Nmap, recommends setting this somewhere between 100 milliseconds and 1000 milliseconds, depending on network latency. The host timeout value specifies the timeout of the host itself. That means the entire time it takes to scan the host. Be very careful when you're messing with this value, or you'll have a lot of accidental timeouts and lose everything. With that, I would say that this is, without a doubt, one of the most important settings to tweak on large-scale networks. The default T4 scan will never time out. Even the insane T5 scan will only time out the host after 15 minutes. Nmap scans 64 hosts at a time. While you can change how many hosts Nmap scans at once, you still need to watch out for dead zones, large enough areas of address space that don't have any live hosts. What that means is that if you have at least 64 sequential addresses without hosts on a network that blocks or rejects ICMP or ping communication, Nmap will continue to communicate with those until all other timeouts expire, which can take a very long time. On large networks, I've ran into issues where every other address has a live host. So in the first 64 addresses that Nmap tries to scan, 32 reply and 32 are still scanning. After those initial 32 replies, it scans the next 32 because that's how much capacity is left in the queue. 16 reply and 16 continue scanning. Nmap will continue in this order until all 64 buffers are consumed with hosts that will never reply and will wait for them to time out. The only way to get around this limitation of Nmap is to properly set the host timeout. On reliable networks, depending on what type of scan I'm doing, I'll set this to about 5 or 10 minutes. Now that we've covered performance tuning, let's take a look at our scanning methodology and the types of scans that we'll want to perform. At a high level, we want to filter our host list and our port list before we dive into deeper information scans. Instead of using a single command to do all these tasks, I like to break down my scanning into multiple phases. These phases can be broken down even further by breaking up the large network ranges into 512 or 1024 chunk blocks. Breaking down scans into smaller phases allows us to analyze the results at each phase so that we can identify any issues along the way. It also gives us the advantage of looking at partial data without having to wait for everything to complete before we begin our analysis. The most detailed scan that we can do is a 65K port scan. So here are the necessary phases to get there, and always configure all outputs with the -OA flag set. First, according to Nmap research, the top 1000 ports list account for about 93% of all network service ports. So that's where we're going to start, with the default top 1000 port scan. Depending on the network, we may want to disable ICMP host verification, or no ping, so that we can still identify host services when ICMP messages are blocked. Next, we're going to perform a second scan on the full network list, but this time it will be an ICMP, or ping-only scan. This is also known as a ping sweep. These first two scans will allow us to identify hosts that either have open services and ICMP disabled, or hosts that do not have any of the top 1000 ports open, but are live on the network. We still might want to be able to perform OS detection on them, or see if they have any other obscure services running outside of the top 1000. This third phase is optional. Here, we'll take the results from the first two scans and filter down to hosts that we know for sure are alive, and perform a full open-close port scan on all 65,000 ports. This will allow us to check and see if any obscure services are running on these systems. And finally, we'll take our filtered list of specific ports and specific addresses that we know are alive and open and perform our deep scan. -A will perform service discovery, default scripts, and OS detection on our identified systems. As we go through each of these phases, we'll want to analyze the results and pipe them into the next phase. So with that, let's talk about the last little bit, how to analyze the Nmap data. Earlier, when I said that you always want to use the all outputs -OA flag, here's why. While the Nmap and the grep outputs are great for looking at Nmap data through a terminal or filtering through a script, the one that's the most important, in my opinion, is the XML output. The reason for this is because we can use an Nmap XML to CSV script in order to convert our data into a much more usable form. In the description below, I have a link for this script, which all we need to do is import the XML output, and it will convert it to a CSV file. Once we have that information, we can open it up in Excel as a spreadsheet or import it to a database. The first thing that I like to do with a spreadsheet like this is insert table and make sure that the My Table has headers is checked so that we can better filter our data. The next thing I'll do is go to Insert Pivot Table, and we'll create a pivot table. Pivot tables are a little bit more of an advanced concept when it comes to Excel, but here's how they're useful. We can select the data like an IP address, put in the port number, and the service that is being used. And then we're going to change the design and turn off all subtotals, all grand totals, and for this instance, we're going to set the report layout to tabular form. Here, we have the ability to look at each IP address and see what ports are open on those addresses, along with that service associated with that port. We can also use this information in order to filter down and get all of our live IP addresses by making sure that only the IP is checked. And we can do the same thing by swapping the IP for the port, and now we have all of our port numbers that are associated with this network. In our first two phases, our goal is to filter down IP addresses to only the live IP addresses on the network. We can put them into a pivot table like this, and then perform a wider scan on all 65,000 ports. Once our third phase is complete, we can put it into a pivot table again and collect all of the open ports on that network. And that's where the fourth phase comes in. We take our filtered IP addresses, we take our filtered ports, and we perform the deep service scan. Once the deep service scan is done, we can put it into a final pivot table and it'll give us all of our results. Let's take this a step further. A common network scanning scenario is where we would want to scan for multiple points in a network to see who is able to talk to whom. A perfect example of this is PCI networks, where we want to see if anything in the cardholder network can talk to anything outside of the cardholder network, and vice versa. In this second spreadsheet, I have an example where we have the Linux network, the Windows network, and then a monitoring network. What we can do is create a new spreadsheet where we have all of the data and insert a new column called From System, so we can see where we were scanning from. After that, we can create a pivot table, just like we did before, and we can filter it down by From System, IP, Port, Service, and Product. That way we can see what networks are able to talk to what systems. If we add Operating System, in front of our from system, we can see that the Linux network has a bunch of Linux systems inside of it. But here we have a blank operating system that was received. And if we scroll over to the services, we see that it's running Microsoft IIS and has some Windows RPC services. If we scroll back up to the Windows network, we can see that all of the services are Windows related. And even this one address that doesn't have an operating system, we can see that it has Windows RPC ports open, indicating that it's likely a Windows system. When you're dealing with large-scale networks, it's very important to be able to analyze the data that you're receiving. In this video, we covered how to tweak our performance settings and perform a scanning methodology using multiple phases. And at each phase, we analyzed our data to get a list of live IP addresses, open port numbers, and full port number service accounting. Well, that's all I have for you guys today. For more information, check out the links in the description below. And if you'd like me to make more advanced Nmap videos, leave a comment, or let me know what other topics you'd be interested in. And don't forget to like and subscribe to see more videos like this. I'll see you next time.